Okay, so now it's basically the same in adding and subtracting as looking at the decimal places. That's not quite accurate in a sense, but I'll show you here in a second why that is. So let me just look here at an example with you. So let's say we're going to add together these two numbers, okay? Now one thing when you're adding and you're subtracting that's really nice to do is try to line up the places. So you notice here how I have the ones, the tenths, the hundredths lined up. That'll really help you when you're adding and subtracting. Okay, so again, it's not just sig figs. So it's not like, oh, 4.1 has 2 sig figs, 3.75 has 3 sig figs, 2 is the fewest, so it's 2. That's not how you do it when you're adding and subtracting. So the way it's going to work is, okay, so in 4.1 then, on this one, for example, where then in this one is the last significant digit in a sense? Okay, so 4.1 does have 2 sig figs, and the last one is in the tenths place, right? You agree with me on that? Right, so this one here. So this one then, 4.1 then is, what's the word? Precise out to the tenths place, right? The 3.75 is precise out to the what? Hundredths place. Aha. So in that case, when we're adding then our least precise is to the tenths place. So the answer can only be to the tenths place. Does that make sense? So one little thing that I like to do is just draw a line then after whatever that was. I'm going to draw a line right here. There you go. So if that's tenths, that's hundredths, the answer can only be tenths. So I'd round that off, and what would you get when you round that? 7.9, right? Perfect. Okay, so like I said, it's slightly different from the multiplying and dividing, right? It's not just sig figs. Now it's just the uncertainty with your places in a sense. Okay, so let me show you a couple more to make sense here, hopefully. Okay, let me try 4973 minus 342.18 liters. Again, I really encourage you to try to line up the places. So I'm going to go ahead and line up 4973 with 342.18. You with me? Okay, so I'm going to grab my calculator. You can grab yours and we'll play along here. So, 4973 minus 342.18. I got 4630.82 liters. Yeah, that's a liter over there, sorry. Okay, so I want to look at the sig figs. Is that wrong? Give me like a weird look.
How'd you get the 82?
Minus? Are you subtracting, right?
Yeah.
So this is really 0.00, right?
Okay.
So 8 minus 0 is 2, and then take one from here, 9 minus 1 is 8. And then just went on there. You just punch it in there in your calculator, just spit that right out of you. Okay, so the first one has 4 sig figs. Where's the last sig fig?
3.
The 3, right? Yeah, the 3, right? Which is in the ones place. So this one is precise out to the ones place, right?
Mm-hmm.
This one has 5 sig figs. The last one's where?
8 hundredths.
The hundredths place, the 8, right? Okay, so ones or hundredths, which is less precise?
Ones.
Ones. So I'm just going to draw a little line after the ones. We're going to round off to the ones. That makes sense. So how would I round that off to show me just the ones place? So 8 tells me to do what? Round up, so 4631 liters. Okay, so I'll say again, right? It's not just saying, oh, 4 sig figs, 5 sig figs, 4 is the fewest. It does work out that way sometimes, but that's not the way we're doing it. We're doing it with the places in a sense. Are you with me? Good, you're with me. Okay, good. Okay, let's try another one. Okay, so again, have these numbers, try and line them up, right? Let's try and line them up. I'm gonna line up 2, 3, 5, and then I'm gonna line it up 19.6, And I'm going to line up 2. Right? These are all grams. Grams, grams, grams. So I add this up, and I get what? 5, 6, 7, 6, 1, 2, 5, 6.65 grams. Is that right? I think that's right. Okay, so let's look over here. Okay, let's look over here and look then at our places. So 235.05, how many sig figs? 5, and the last one is in which position? The hundredths. Okay, so this one can only go out to hundredths. Okay, 19.6 has 3 sig figs, and the last one's in the 10th place. Okay, good. Yes?
I'm sorry. I'm just really confused because the last time you calculated it and it came out to 0.82.
Mm-hmm.
But this one, you just dropped down like the 5 and the 6. So why wouldn't you do that with the last one? Why wouldn't it just be?
That was subtraction. This is
Is
adding.
it different?
Yes.
Okay.
Yeah.
You just never showed us the subtracting before, so I think that's why I got confused. You did like adding.
I mean, it's the same sig fig rule. It's just the way you do the math is different when you add and subtract, right?
Maybe I just need a calculator. I'm just doing it in my head. That's okay.
Okay, 1 second then. 1 second then here. First on this one here. This one here then. And I'll go back. So 2 has 1 sig fig, and the last one's in the ones place. Okay, so ones, tenths, or hundredths. Which is the least precise? So I'm limited to the ones place. Yes, you're getting it. I like learning. So, what do you think? How about I round that off then? 257 grams. Makes sense? Okay, so go ahead and try C and D on your handout. I'm going to go back and... Oh, I didn't do A? Oh, I'm sorry. Oh, whoops. Okay. Okay, sorry about that. Okay, so do A and D then. Sorry. Do A and D. Yeah, that was B and C. Okay, let me look over here and show her, since you're asking about B.
I got it now.
Got it?
Yeah.
Okay.
I understand.
Okay, so go ahead and try A. Again, print out the handout. Saves you so much time. You don't have to write down the question. You can just answer the question. So print it out or email it to you twice, and it's on Blackboard, so saves you so much time. So you try that out. Line them up. Do whatever you got to do. Again, I'm encouraging you to line them up helps when you're first learning this stuff. As you go on, you can just skip the lining up. But at least for now, it's nice. Sorry, I got my big water in your way here. I'm going to call roll while you're doing that. See, people are not here, so I might ask people to drop. So, okay, so just wave at me or something, or say here if I can see who you are. Nicole, okay. Nicholas, great. Daniel,
Here.
thank you. Hilda,
Here.
Chrissy,
Here.
we're here. Marilia, Shane, awesome. Arturo, okay. Angel,
Here.
Mariella, Araceli, Colin,
Here.
okay, awesome. Lauren, Aaron, Haley,
Here.
Valerie, no Valerie, Salome, is that right? I can't remember. Okay. Odalise, I think that told me how to pronounce it, right? Okay. Oh my gosh, you got it right. Can't believe it. Reedon, I wrote it down. Reed with a little line, I don't remember. Okay. Marlise.
Here.
Marlise?
Yes.
Is that right? Okay. Brandon. Where's Brandon? Sorry. Awesome. Leslie.
Here.
Awesome. Kendall.
Here.
Okay. Naya.
Here.
Sydney. Tina. No Tina. Shanice.
Here.
Okay. And Liliana.
Here.
And then my waitlist people, I think I added, did I add Diana? and Sasha. Okay. And is Alec here again? You show up last one. Okay. Okay. Well, I'll call roll again at the end for the late people. Okay. So go ahead on this one, and compare with your neighbor. Yeah, compare with your neighbor. Maybe meet him again if you forgot their name. Say, oh, hey, by the way, my name's, what's your name again? What's your name again? My name is Susie. Whatever it is, right? So try it again.
For 8? I don't believe why'd you add 9-1? None of that. I think whenever you're doing adding, it's easier to like put a bigger digit on top. Because that way you can line it up. It's easier. It's like 14.82 and then plus 0.0291.
Okay, so I lined them up and I got something like that. How many sig figs should I have? What do you think?
Oh, wait, yeah.
Not how many sig figs, how many places I should say?
4.
Out to which place? Hundreds, thousands, millions? What should I be at?
Hundreds.
Hundreds, right. So this one's out to the hundreds. Oops, we're not writing here. This one's out to the 10,000ths. So the least precise is the hundreds, right? Make sense? So you round it off to be what?
14.85 inches.
14.85 inches. Is that what you got? Okay, let's try D. If you haven't yet. Whoops, went too crazy. Okay, so what'd you get on D? Compare with somebody. See what you guys got for D. So same thing, we're going to line them up. I'm going to line up 58.925 minus 18.2. So what is that, 40.725? Is that right? Is that what you got? Okay. So, okay. What'd you get? What's the answer?
40.7.
40.7? Yeah. Ounces. Thank you. OZ. Yeah, so this one's out to the thousands. This one's out to the hundreds. So the fewest is hundred. What's that called? Tenths. Tenths. So we'll go to the tenths, right? So, right. 40.7 ounces. OZ. Oh, ounces. Okay, what do you think? Does that make sense? Okay, so again, as I said, right, so multiplying and dividing is fewest sig figs. Adding and subtracting is the fewest places, if you will, right? Tens versus hundreds. Yeah.
So for one that has multiplication and addition, which rule do you follow?
Both. Well, so you follow the multiplying then other for that step, and the adding for the adding step. So you go back and forth between the different rules depending on what you're doing. So first step is.
But then I like the very end of all the when you finally calculated the answer and you're rounding.
Okay. Let's do one.
It's just kind of like the same thing.
Let's do one.
Okay.
Let's clear this all out. Okay. Let's say I'm going to take, I don't know. Okay, why is this not working? Here we go. I don't know. 97 times 1.43 plus 2.1, whatever. I don't know. I'm just making it up here, okay? Okay, so remember way back in your math class, you probably had this thing called the order of operations, right? Which tells you which one to do first. So what do you do first? Do you multiply first or do you add first? You multiply first. So first thing I'm going to do is I'm going to take 97 times 1.43. And what's that give me? Let's see. 97 times 1.43. Yeah. We don't normally get quite this advanced in 100, but I'm just going to show you in case it comes up on a homework or something. I don't think it will, but 138.71. Okay, so now I multiplied. Now the rule for multiplying is fewest sig figs, right? So 97 has how many sig figs? 2. 1.43 has 3. So my answer should only have 2. But I told you, don't round till you get to the end, right? Wait to the end. So what I'm going to do is I'm going to mark it just to remember where it's at. So I'm going to mark it as, oh, it's really right there, but I'm not going to round it yet. Now I'm going to do the next step. I'm going to add, so whatever are your significant digits, and then we're going to multiply it by some power of 10. So I'll show you an example here in a second. So that's what you're going to do. Is if you have, let's say, for example, 3 sig figs, pull out the 3 sig figs. If you get 5, pull out all 5. And we're going to multiply by some power of 10. So the question is, how do you know what power of 10 to multiply by? Well, that just depends on the number you were coming from. Was it a really big number or was it a really small number? Okay, have that scribbled down? Okay. I guess you do because somebody's screaming at me. So I'm going to go on. Okay, so what you're going to do is you're going to put a decimal after the first significant one, and then we're going to use a power of 10. So if it's a really big number, let's say it's a number then that's bigger than 1, you're going to have a positive power of 10. So for example, right here, 150. See that 150? So this is obviously bigger than 1, right? 150. So how many of those digits, though, are then actually significant? Out of the 1, the 5, and the 0, how many are significant? Just the 2. Just 2 of them, right? Right, the 0 is not because there's no decimal. So the 1 and the 5 are significant, so I'm going to pull out the 1 and the 5. 1 and the 5. So it says put the decimal after the first one. So I'm going to put it right here. So I'm going to put it after the first significant figure, after the 1. Okay, then I want to write that as 10 to the something. So 150 is the same as saying 1.5 times 100. And 100 is the same as 10 times 10, which is 10 squared. So, what you can really kind of think of it like this. So really, in a sense, there was a decimal like right here. It's not showing. But I had to move it 2 places to get it between the 1 and the 5. Does that make sense? No? Okay, so if I have 150, so I want to get this times 10 to the something. Well, the decimal was really there, right? It's not shown, so it has to go 2 places to get to here. Oh, so it's 10 to the 2. It had to move 2 places. Because this, 1.5 times 10 twice, is the same as 150. All this is a shorter way of writing 150. And this one then is nice because it doesn't show you all these crazy placeholder zeros then. It only shows you the ones that are actually significant. It doesn't show you all the extra zeros. Yeah, I think that's all I hand. Yeah, read.
So would 0.15 times 10 to the third be an acceptable answer, or is there like a certain, does it have to be at 1.5?
We always put the decimal after the first significant digit.
Okay.
Yeah, so don't put it here, don't put it here, put it after the first one. Is the way we do it. Okay, so that's it. So if it's greater than 1, it's going to be a 10 to a positive number. Now, if it's less than 1, let's say it's 0.0075. Okay, well that's less than 1. So, okay, so here again, 0.0075, we have 2 sig figs, right? The front zeros are not significant, agreed? So only these 2 are. So what I do then again, is I'll pull out the 7 and the 5 by themselves. Put the decimal after the first one, and the figure up. Okay, so how many times then did that decimal have to move from here to get over here after the 7? So it has to go 1, 2, 3 times, right? Okay, so that means basically what you're doing is this number is being divided by 10 3 times to make it smaller. Are you kind of with me? Because with 7.5, okay, so 1 time by 10 would make it 0.75. Divided again by 10 would be 0.075. Divided again by 10, then you'd get 0.0075. So now that becomes 1 over 10 3 times, which we call it negative 3. So here's a little math flashback, right? A negative exponent, that's the same as saying now you're dividing by it 3 times. Right? Are you sure? So this is the same as 1 over 10 to the third. Right, because that's a negative exponent. That means, or 1 over 10 times 1 over 10 times 1 over 10 3 times. So you're dividing by 10. Okay, so let's try a couple. It got really quiet, which is normally not a good sign. Okay, so I'm going to show you a big, scary number. Okay, so as I was saying, here's an example then of a large number you might use in science. So this is the number of atoms in just a single liter. I mean, a single liter of helium. Not much helium, but there are bazillions of atoms because atoms are so freakishly small. So obviously then, trying to write this number over and over would be a real pain in the butt, right? Trying to keep track of all those zeros. So it's much easier to use scientific notation. So let's figure out, okay, so first off, how many sig figs are in that number? 3 sig figs, and they are what? The 2, the 6, and the 8, right? So I'll put a 0 right here after the first one. And then I want to count. Okay, so the decimal is kind of understood to be here. How many times I got to move it to get it between the 2 and the 6?
28. 22.
22. Okay, so 3, 6, 9, 12, 15, 18, 21, 22. So I have to move 22. So yes, this obviously much easier to write than this over and over, right? Would you agree with me? Yes. Yes, that is a much shorter way to write that. Plus it clearly shows, oh, these are the 3 sig figs. Does that make sense? Yeah, okay. So that's a big one. How about doing a small one? So let's take a really small one. So this, for example, is the length between 2 carbon atoms in a little small molecule of benzene. So let's look here. So how many sig figs are in that number? 2 or 3?
3.
Aha, yes, right, 3. So in this case, the 0 is significant. Why? Because of this decimal. So the 1, the 4, and the 0 are significant. Where's the decimal go?
After the 1.
Yeah, after between the 1 and the 4. Okay, so it was here. How many times would I have to move it from here to after the 1? 7, right? Let's do it here. So 1, 2, 3, 4, 5, 6, 7. 7 times. So now, though, it's a small number. So it's 10 to the, negative 7. Does that make sense? So in order to make this number really small, I've got to divide by 10 7 times. It's going to be a negative 7. So again, small numbers less than 1 have a negative exponent. Big numbers greater than 1 have a positive exponent. Got that? Okay, let's try some. Okay, let's do this one together. 2,400,000. Anybody know that symbol yet? What it means? Micrograms. Oh, high five. Yes, micrograms. Oh, you're gonna kill me. Okay, micrograms. Okay, so how many sig figs are in that number? Okay, so let's go ahead and pull. Yeah, so let's go ahead and pull out the 2 that are significant, which are the 2 and the 4. Right? The decimal goes after the first one. How many times do I have to move it though, to get it over there between the 2 and the 4? So is that positive 6 or negative 6? Okay, right. Yeah, right. Because obviously 2 million is much bigger than 1, so it's going to be a positive number. So positive 6 micrograms. Okay, 0.00256. So same thing. We have 3 sig figs. So I will just rewrite those 3 sig figs: the 2, the 5, and the 6. Right? Decimal goes after the first one. And now I'm going to multiply it times 10 to the watt now. So 1, 2, 3. But it's a smaller one, so it's negative 3. Yes, good. Okay. So this way over here, by the way, is called standard notation, or you might hear it called decimal notation. And this obviously then over here then is scientific notation. Okay, so now I'm giving you one here then. It's already in scientific notation. And we're going to go back to the standard notation, or the decimal notation. So 10 to the negative 5th. So that means the 7 is being divided by 10 5 times. So then the end number will be what? Greater than 1 or less than 1? Less than 1. So really, I'm going to go ahead and write the 7. And I'm going to move that decimal left or right? Left 5 times. Are you with me? 1, 2, 3, 4, 5. So 0, 0, 0, 0. And I was going to put one here in the front, just as a little eyeball catcher. So that would be your answer, right? That makes sense? Because the other way would be 5. So we just go backwards now, 5. Questions? Couldn't be clearer? Okay. Okay, how about 6.2 times 10 to the 4th? Oh, okay. Well, that must be a bigger number. So now the decimal will move to the right how many times? 4 times. My gosh, you're getting it. So 1, 2, 3, 4. So 0, 0, 0. So it'd be 62,000. Okay, so it's a quick little note though. Notice when I moved it, I did not write it like this. Why did I not actually show the decimal? But yes, but why specifically?
Because there's only 2 significant.
2 sig figs, right? So here's 2 sig figs, here's 2 sig figs. Otherwise, that would be how many sig figs?
5.
That would be 5 sig figs, right? Right? Okay, yeah. So from here to here, you always keep the same number of sig figs. So if that's 2, that's 2. If that's 3, that's 3. That's 1, that's 1. That's 2, you're going to have 2 when you get done, right? So you can't change the precision. All we're just changing then, is the way we write the number. Okay. So let's pull out your handout. I think we got some on the handout there. Okay, so yes, so go ahead, I don't know, try the first 4 or 5, and then we'll compare with the neighbor here in a second. So I'll say again, right? So how many sig figs you have originally? Make sure you have that many sig figs when you get done. So if there's 3 to start, there'll be 3 when you're done. If there's 6 when you start, there'll be 6 when you're done. You don't change the number of sig figs. All you lose are the placeholder zeros. Okay. So this one here, how many sig figs were there on these?
5.
Yeah, 5. But on here you only have 2. So what happened to those sig figs? You got to take all the ones that are significant, put them over here. So 4.2784. That's a quick question. Okay, so here you have 120, and there was no decimal on the end, which means there was how many sig figs? Yes, only the 1 and the 2 should go over here. The 0 doesn't come with you. Yes, there you go. Perfect.
It should be positive 2. When it's negative, that's when you're using that. Okay. So when it's negative, you move the decimal forward. When it's positive, you move it back. Since this is yes.
Okay, we'll talk it over with somebody. Help each other out. Check your answers. See if you guys agree. Help somebody out. Don't be shy. Make a new buddy. Could be a future lab partner.
Yep.
Yeah.
For that one has 4 significant digits because it has a decimal point. So you write 4.300. Yep. Because if it didn't have the decimal point, it would only be 4.3. Since it has a decimal point.
Okay, so I'm going to go ahead and start running through it just for time's sake, so we can get. Okay, so remember, take out whichever digits are significant, right? Only take those out. So the first one, it's easy. All 5 are significant, right? So you pull out the 4, the 2, the 7, the 8, and the 4. They all come out. They're all significant. Decimal goes after the first one, and I had to move it 1, 2, 3, 4 times. So times 10 to the 4th. Okay. 120. How many sig figs in that?
2.
Okay, so only the 1 and the 2, right? The 0 was not significant because there was no decimal. Right? So I put the decimal after the 1 and the 1, and it has to move how many times? 2. So positive 2 or negative 2? Positive 2 miles. Awesome. Okay, how many sig figs are in this one? How many? 7. So take all 7, right? Rewrite them all again. Yeah, so don't lose any. 9, 8, 4, 2. Got to write them all again. And I put it after the first one. So how many places now did I move it? 10 to the 3, right? 1, 2, 3. So far, so good? Or if not, maybe you're learning. That's okay. Okay, 0.0819. How many sig figs?
3.
Okay, the 8, the 1, and the 9, right? The 8, the 1, and the 9. So I put the decimal after the 8, and I had to move it how many times? Positive or negative now? But now it's negative, right? Because it's going the other way. It was a small number to begin with. So negative 2 seconds. Okay, let's go back up here. How many sig figs are in this one? Go ahead and erase those. Okay, 6. So rewrite all of them, right? So don't leave out any of those ones that are actually important. The first ones you can drop, right? But you got to keep those 6. Does that make sense? Right? The first ones were not significant, so I didn't write them again. These are, so I wrote those again. Right? Okay. Put the decimal after the 2. Try that again. And I moved it how many times? 4. Negative or positive? Negative 4. Okay, how many sig figs in this one? There is an end decimal, right? So there's 4. So rewrite all the ones that are significant. The 4, the 3, the 0, and the 0. So not just 4.3, right? Right? You see why it's not 4.3? Right? Okay. Because the 4.3 would have only been 2 sig figs compared to 4. You would have lost 2. So you can't lose them. Just rewrite them all. So times 10 to the what? Third pounds. Okay. 86.00. How'd you write that one? 8.6. How many sig figs were there? 4. So you got to have 4 here. 0, 0. Yeah, right? So if you got 4 to start with, you got to have 4 and you're done. So times 10 to the, or just 1 or nothing, right? You can put 1 if you want. But okay, and the last one, 5.53092 times 10 to the what? Negative 1 milliseconds. Okay. Got it on that one? See what the zeros are there? Okay. Okay, so let's just try a few the other way. And then we're going to have to fly on here because... Okay, okay. Okay, yeah, just go ahead then, yeah. And just try the first 6 here. Real quickly by yourself, compare with the neighbor. I'll give you like 2 minutes just for time's sake. Because you guys have 2 less class periods than my other CHEM 100, so we gotta play a little catch up. We have 2 holidays they don't have on my Tuesday, Thursday class. So. 0.092 times 10 to the negative 1.
5.53.
0.92 times 10 to the negative 1.
Okay.
There you go. Okay, well, same thing, you know. Compare and contrast the ones you got done at least. Maybe you can get them all quite done yet. You know, just compare the couple you got done. So now we're going the other way. We're taking the notation from scientific over to decimal or standard notation. Make sure you keep the sig figs when you get done. So if you had 3 to start, you better have 3 at the end. If you had 4 to start, you better have 4 at the end. You should not lose precision. Okay, I'm going to start going over it again just for time's sake. Okay, we got 5.390. So that's how many sig figs? 3 or 4 sig figs? That's 4 sig figs. Okay, so I got 4 to start with. I better have 4 when I get done, right? So I'm going to rewrite all the significant figures: the 5, the 3, the 9, the 0, and I'm going to move the decimal places to the left or the right? To the right, right? Because multiplying by 10 twice makes it 100 times bigger. It's going to wind up being right there. So 539.0. You see that little decimal? I'm trying to make it bigger so you can see it. Okay. 3.4 times 10 to the negative fifth. Well, obviously, the 3 and the 4 are significant. The decimal has to move 5 times, but now to the left, right? So I'll just show it here. 1, 2, 3, 4, 5. So 0.00034 meters squared. Okay. How about this one? Somebody here. It worked kind of weird because the decimal should go to the first one, but they were not paying attention. So 10 to the second moves the decimal 2 places, left or right? Right again. So I'm going to get, what I get here? Somebody just tell me. 77.8 or 80? Yeah, the 0 is significant because of the decimal, right? So there's 6 to begin with, but I have 6 when I get done. Yeah, so don't lose that 0. Okay, 6.03 times 10 to the negative third. So 0.00603. All right. 2.500 times 10 to the negative 2. Well, again, that has 4 sig fig. Right? These zeros at the end are significant. So when I got so these zeros down at the end better be there in the end again, right? So 0.02500 degrees Fahrenheit. Is that what you got? Maybe? Some of you? Okay. And then this one times 10 to the third. So 1, 2, 3, 4, 5, 6, 7 sig figs to begin with. So I better still have 7 sig figs when I get done. So I'm going to move that to the right 3 places. 1883.200 hours. Question, yeah. C, yes.
How would you end up with 12 if you're supposed to have a decimal point for the first one?
That's what I was saying. The person here that wrote this one, then I guess weren't paying attention because it should always be after the first one. But it still works the same way. We're still, a 2 means move it to the right from its place 2 places to the right, or move it to the left if it's negative, whatever it is. But you're right though, yeah. Normally it should always be after the first one. Okay, well, I want to show you now on your calculator. So hopefully you brought your scientific calculator that you want to use on a quiz or a test. I want to show you how to enter in these big numbers on your calculator. So first off, just try that out on your calculator and see what you get. Just try it out. You will either get one of 2 numbers. You'll get one of these two numbers, depending on the way you enter it, if you enter it the right way or the wrong way. Okay, so hopefully you got it the top way. If you got the bottom way, you do not know how to use scientific notation yet, which is okay. That's okay. It's okay, because we're here to learn how to use exponents. So you have a handy key on your calculator, if it's a scientific one, that actually knows how to do exponents intelligently. So again, I told you before, if you just enter it in straight like this, it'll say this times this divided by this, but then it'll put this on top again to multiply it. It's not smart enough to know. But there is a very easy way without having to use parentheses 47 times and all that kind of crap. So you have a key that looks like one of these two, either EXP or EE. So hunt around and look for a key that looks like EXP or EE. Do you see a key that looks like that? Maybe? So on some calculators, it's right over the log key. It'll say log, right above the log it'll say EE, like on this one here. Or it's right over the little x to the negative 1 key. You see where it says EE? Okay, this is a beautiful key because it saves you lots of keystrokes. So that little key right there, that key means times 10 to the whatever. So it saves you having to put in times 10 to the power, and also saves you all the parentheses. So the easy way then to enter this is 5.44, hit that key, 7. So that means 5.44 times 10 to the 7th. And then divided by, 8.1, hit that key again, 4. And you should get that number, 671. Okay. This, again, much easier than writing out the whole thing, right? Doing 5.44 times 10 to the 7th. Oh, wait, I forgot. Parentheses, divided by parentheses 8.1 times 10 to the 4 parentheses. That takes forever, right? This is only 1, 2, 3, 4, 5, 6, 7 keys. This is like 15 keys. So I'm saying, plus you're going to have much more room for error than the more keys you got to enter in. So this is your new friend, the exponent key. Okay, so try it again. Did you try now the exponent key? Did y'all get that now? Okay, so I'll tell you what. I said bring them on Wednesday, and I will make sure then on Wednesday, then we go back again and we practice this with the exponent key because you're using this key a lot this semester. A lot. Okay, so let's look at measurement, and then we'll have to use that exponent key some more here in a second. Okay, well, as you know probably, in science, we don't normally use the English system of pounds and, feet and miles and things. And we don't technically even use the metric system. Actually, the one we use is the SI system, which comes from the French then, from the French here, as you can see, Système International d'Unité, which is basically based off of the metric system, but it has one small little variation. So it is still metric, so the length is still the meter, the mass is still also metric, kilograms, time is seconds. The only difference between this and the metric system is temperature, right? So it's Celsius and metric, but in science we actually use the Kelvin scale. That's the only difference. But it is basically, though, still the metric system, okay? So we're going to use, but it's really called the SI system, or the SI units technically. Okay, so let me just show you a little bit of the metric system. Okay, so here's a fun little pop quiz. Okay, so of the 193 countries approximately then in the whole planet, how many countries still have not officially adopted the metric system?
2.
3. There are 3 powerhouse countries that still hold us. 190 use the metric system. 3 of them do not. Us, of course, the U.S., and which other powerhouse countries do you think they are? Any guesses? No, it's just Liberia and Myanmar. So we are the last 3 countries that do not use the metric system. Even the English do not actually use the English system anymore. Even they have officially adopted the metric system. So we are the last big holdout us, Liberia, and the Myanmar. So yes, it's kind of crazy. Yes, wherever else in the world that anybody want to travel, they're going to be using the metric system. They're going to be using meters and liters and Celsius and all that good stuff. Okay. Well, so how does it work? So if you would, go ahead then and pull out your little green metric sheet I gave you and have that handy as a reference. So basically the way it works is back in the 1700s, the French were really tired then of there not being a nice uniform system of measurements. Because prior to that time, again, they're using the English system, which is really confusing. Right, so for example, for distance, let's say, right, it's 12 inches is a foot, but 5,280 feet is a mile. Or let's say it's volume, it's 16 ounces in a gallon, but then it's so many gallons or in a pint, and so many pints are in a quart, and it's all different numbers, right? 16 or 4 or 12 or what? It's a whole crazy thing. So yes, back in the French Revolution times, it was around 1650 or 60, and they created this committee, and they told them, okay, so go out then and make us a nice, easy to use, standardized system we can use for measurements. We'll just say, screw you, England, we've got our whole nice new system of units. And the one they created then was called the metric system. So basically, I said the way it works is they're going to use prefixes. So every prefix just takes your number and makes it bigger or smaller by some factor of 10. So again, like I was saying, it's not 12 sometimes and 6 sometimes and 5,000 sometimes what it is with the English system. It's always some factor of 10 bigger or some factor of 10 smaller. And the way you tell is by using a prefix like you see in your sheet, like tera or kilo or deci or centi. Okay, so you can use then, the nice thing is then, you can use those same prefixes to make a volume bigger or smaller, or the same ones for a length bigger or smaller, or a mass bigger or smaller. So it works the same for every system. It's not like, again, like I said, English, where it's feet and miles and inches for one thing, but now it's pounds and ounces and tons for one thing, and now it's gallons and quarts and pints. No, it's always the same prefixes for every system to make them bigger or smaller. So it's much more standardized and handy in that sense. Okay. So, for example, 1 kilometer. Okay, so you find kilo on your chart. Kilo means 10 to the third, right? See it on your chart there? So, a kilometer is 10 to the third meters. Okay? A kilogram would be 10 to the third grams. A kilosecond would be 10 to the third seconds. A kiloliter would be 10 to the third liters. See how that works? Okay, how about a terabyte, like in your hard drives, right? So you have a 1 terabyte hard drive. Tera means 10 to the 12th. So a terabyte is 10 to the 12th bytes. Okay? Okay. So that's basically what we're going to do. Is we're going to use these prefixes then as a way to try to make numbers bigger or smaller. So let's look here at the little chart, right? So here's the chart then, right, which you will have learned, as I told you, between now and Wednesday, right? So you have your little flashcards. Hopefully you got the flashcards, right, made up, and you're going through them every day. Yeah.
You need to know the magnitude as well?
Yes. The first 3 columns on there, I said. Okay. Yeah, the prefix, the symbol, and the 10 to the whatever. So you make a flashcard, like I was saying, and on one side just put, peta, and the back side put 10 to the 15th. Another one put kilo, backside put 10 to the 3rd. Just go through those flashcards. You'll know them in no time. Okay, so let's try it. Okay, so here's an interesting little clock that I saw. So I was in Oxford about 3 years ago in England, and I was there. I was visiting there then at this really cool place called the Museum of the History of Science. And this is actually one of the last surviving metric clocks from the French Revolution. So I told you, so back around that time, other than the French, like I said, we're trying to make everything metric, right? So they made metric length, metric volume, metric mass, and they were going to make metric time. So they were going to actually go through. Then you can see then here then on the clock, instead of having 24 hours in a day, they're going to make time into 10 hours a day and 10 days a month. They're going to make everything metric, even the time. But for some reason, though, although length and mass, and the other ones they all caught on. They all caught on, but the time never caught on. So we're gonna actually do that. So you see it's 10 hours, and then there's 10 minutes in an hour, right? Can you see that? I mean, everything's gonna be 10, 10, 10 for everything, even time. So isn't that crazy? So anyway, okay. So let's talk about then trying to convert between, let's say, kilometers and decimeters. Okay. Well, any kind of conversion you want to do, you're going to have to use what's called a conversion factor. And you may also hear those called unit factors. Sometimes you hear that referred to as a unit factor. A unit factor. Okay. So the way that works then is your unit factor is there to help you convert between one unit to another unit. Okay, pretty straightforward. And you've been doing this all your life. So every time you turn feet into inches, or you turn hours into minutes, you are using conversion factors, right? Or you're turning, tablespoons into cups, or miles into hours when you're driving, right? So you're using conversion factors. Okay, so what I'm going to show you, though, is a little bit more kind of like a standardized way of trying to set up your conversions. Okay, so for example, you all know, here's a conversion factor between minutes and seconds, right? 1 minute equals 60 seconds. So when I want to write this, though, now as an actual factor, I could write it one of two ways. Oh, I'm sorry, go back. Okay, back. There's another one I can do, right? 1 mg. M is milli, so you find milli on your chart. It means 10 to the negative third, right? So 1 milligram is 10 to the negative third grams, right? Okay, so what we're going to do then is now, like I said, is use these little factors to convert between minutes and seconds, or between milligrams and grams. Okay, so let me show you. So they always come in pairs. So for example, as I was saying, 1 minute equals 60 seconds. Okay, so there's two ways then to write this as an actual factor, or like a fraction. I could write it as 1 minute per 60 seconds, right? Or I could just always flip it and say, or there's 60 seconds per minute. Same thing then with feet and inches, right? There's 1 foot per 12 inches, or there's 12 inches per 1 foot. Right, that make sense? Maybe? No? So the way you're going to use the factor depends on the units that's being converted. So if you're converting minutes into seconds, you'll use it one way. But if you're converting seconds into minutes, you have to use it the other way. Okay, so I'll just show you a quick little procedure then on this, and then we'll try a few. We get done here at what? 12:20? Okay, so I've got 15 minutes. Okay, good. Okay, so just real quickly then, we're going to use a little process called dimensional analysis. We may hear it also called unit analysis. And all this is, as I was saying, is kind of like a general method of just helping you to set up where you're at, where you want to be, and then plug in all your little unit factors along the way to make them cancel out. Okay, so first thing you're going to do is figure out, okay, so what quantity then do I actually know? Okay, so I know minutes, let's say, or I know milligrams, and what quantity then do I want to be in? Okay, I want to turn that into grams. I want to turn that into seconds. So where am I at? Where's the starting point, and where's the goal? Where's the finish line? So that's the first thing then to figure out. Okay, so then you're going to figure out, okay, so what kind of conversion factors do I know that will help me get from where I'm at to where I want to be? And you're just going to go through there then, and then set in all your conversion factors. And you want to make sure then, as I was saying, that your units are going to cancel. Well, see, if you're starting with units of, let's say, minutes and go to seconds, well, you want to cancel out minutes, and you want to be left with seconds. Or if you're in feet going to inches, well, you want to cancel out feet, and you want to be left with inches. Okay? And then the last step is then just go through, and just punch in all the different numbers in your calculator and see what you actually get. Okay, so that doesn't make much sense right now, but I'll do some examples with you, and then it'll make more sense, I promise. You've been doing this before, like I said, all your life, whenever you convert feet to inches or hours to seconds or whatever. But I'm just showing you, like I said, it's a little more systematized way of doing it. So, okay, so figure out where you're at, where do I want to put, right? Where you're at and what your goal is. Which conversion factors do you know to help you to get there? set them all up, then, so their units will cancel, and just punch it in your calculator and see what you get. Okay, so I'll try real quick. So let's say I want to know how many seconds are in 3.55 minutes. Okay, so I know 3.55 minutes is the starting point, and my goal is to turn it into seconds, right? So I'm starting with 3.55 minutes. I want to turn it into seconds. So that's step one. Okay, so I know this. I want that. Okay, step two says, which conversion factors do you know that will help you get from minutes to seconds? Well, we know 1 minute equals 60 seconds, right? We know that conversion factor. Are you with me? Okay. So I'm going to speed up a little bit. Sorry. Okay, right? And again, we said, right? So this what's the word? Equality then is written either this way or this way, right? So the way I use it depends on what I'm converting. So let's think about this. So if I'm starting with minutes and I want to get seconds, which of these two ways then will cause minutes to cancel out and leave me with seconds? The one on the left or the one on the right?
Right.
Are you with? Okay, right? So this way works because minutes are on top here, minutes are on bottom here, so I would cancel out minutes and I'd be left with seconds. This way doesn't work because now I get minutes squared per second. Do you see how I chose this one? So whatever unit's on top here has to be on the bottom in the conversion factor. Then it will cancel out. Maybe? Yes? Okay. So you want to cancel them out. So yes, the second one will work, right? So now minutes would cancel, and I would punch it in, and I'd be left with seconds, which is what I wanted. Okay, I think you got that. So, and the last step, like I said, I would just go through then and punch this in your calculator. So I'll say it again. Whatever's on the top, you're going to multiply by. What's on the bottom, you're going to divide by. So 3.55 times 60 divided by 1. But you're going to go 1 out, of course, because it's a 1. But yeah, you punch that in and you would get 213. Okay, so just a real quick sig fig question. 3.55 minutes is of course a measurement. So that one is 3 significant figures. Is 60 seconds, is that a measurement?
Yeah.
Has that been measured?
No.
No. What? It's been defined or counted, right? Remember that before we said it, right? So we said then, so this one has been, work with me. This one is exact, right? This one has been defined to be true, right? So that one does not have sig figs. So this one is 3 sig figs, but that one has been defined to be true. So it's not, so 60 is not 1 sig fig, right? That is exactly 60.0000 forever, right? That's been defined to be true. So yes, so you're multiplying, 3 sig figs, infinite sig figs. The answer should have the fewest is 3 sig figs. Does that kind of make sense? Okay, well, if not, then it soon will. Okay, so let's look here. Okay, so let's look here. Okay, so how do you know then when to count the sig figs and the conversions and when to not? It's pretty straightforward. Okay, so they're always going to be exact, which means, again, no sig figs, if you are staying within the same system. So whenever you convert an English unit like feet into an English unit like inches, that has been defined, that is exact, there's no sig figs. Or yard into feet, right? Yard and feet are both English. That's been defined, right? It's not a measurement. That's been defined. That is exact. 1 gallon is 4 quarts. Those are both English. That's been defined. That's exact. No sig figs to worry about. Or again, metric to metric. Same system. So kilometers is 10 to the 3rd meters. That's been defined, right? That makes sense? So English to English, metric to metric, those are always exact conversions. No sig figs to worry about. The ones where you have to worry about them then is when you want to convert, let's say, English into metric. Okay, so those have not been defined. Somebody had to sit down, they had to weigh out a pound in grams, or they had to weigh out a gallon in liters, and those had to be measured. So those are not exact whenever you go from English to metric. Okay? So exact numbers, remember we said are counting numbers, right? No sig figs. defined quantities, right? Which would be English, English, or metric, metric, now we know. And the 1 is always exact. Okay, so like 1 foot is 12 inches. Okay, the 1's always exact. Okay, the 1's not 1 sig fig. The 1's always exact. So counting numbers, and then either English, English, or metric, metric, and then the 1 is always exact. Okay, I'm trying to pause, but I can't pause too long. We gotta get on. If all else fails, like I said, it's all in the PowerPoint, or go watch the video. Okay, as I was saying, oh my gosh, I heard some grumbling. Let me go back one second. Okay, like I said, but English to metric, now like I said, those have been measured, right? Somebody had to sit down and figure out how many grams are in a pound. I don't know, so they had to actually get a pound and weigh it, right? So now those are measurements. So that would limit your answer to only 3 sig figs, because that's 3 sig figs. Or how many quarts are in a liter? Well, I don't know, so you got to get out a liter and measure it out in quarts, right? So that would be 1, 2, 3, 4 sig figs. Does that make sense? So English to English, exact, no sig figs. Metric, metric, exact, defined, no sig figs. It's when you cross between the two systems, that's when you got to start counting the sig figs. And your answer then at the end here for the first one would have a max of 3 sig figs, right? Or here it'd have a max of 4 sig figs. Does that make sense? Some of you? Okay, good. Okay, so English to metric, that's when you got to worry about counting the sig figs, when we're crossing the streams here. Okay, so those will affect it. Now there is, however, been defined 1 metric to English conversion. So sometime, I think it was around 1970, scientists then were finally, they were so tired of there not being any kind of connection between English and metric, so we said, okay, fine, then forget it. 1 inch, 1 inch then, 1 inch then, 1 inch then, 1 inch then, is now being defined to be 2.54 centimeters. So that is the only exact connection between English and metric. Every other metric English one is going to be inexact, if you count the sig figs. But this one here, so circle this one, put a big star by it, highlight it. This is the only exact metric to English one. Okay, so that one then was defined to be close enough for calling it exact back in like 1970. Okay. So get all the other ones metric to English, you got to count sig figs. Okay, so let me try to show you an example for right at a time here in the next 4 minutes. So I got that written down. That's the only exact metric to English one. Okay, so let's try. Okay, so here's one. Here's one. Your small intestines are about 6 meters in length. How long is that in centimeters? So the question is, what am I starting with? What's my goal? So I'm starting with what? 6 meters, and my goal is to turn that into centimeters. Awesome. Okay, let me try it. Let me make a little board here. So 6 meters, and I want to turn that into centimeters, right? Okay, so what conversion factor do I know between meters and centimeters? Well, hopefully by now you have looked at your little chart, and you find centi on there, and centi means 10 to the... Okay, so here's the question. Is it 10 to the negative second meters is a centimeter, or is it a meter is 10 to the negative second centimeters? Okay, well, centi means 10 to the negative second. So if centi is on the right side, then what it means has to be on the opposite side. So it's over here. Because this is the same thing as saying centimeters. Are you with me? So now I made it equal. Centimeters equals centimeters. You see how that works? No. Right, because over here, if I did it this way, well, now I said meter equals centimeter. Are you with me? So now I'm saying, oh, a centimeter is a centimeter. Right? So this side is just going to be just a 1. Just put a 1 in there. Okay, so here is my quick rule of thumb that will save your bacon. This is my big number 1 tip with the metric system. If your prefix is on one side, the exponent has to always be on the other side. So for example, here's my prefix on the right side, so my exponent has to be on the opposite side. They can never be together like they are here. You see what I'm saying? If you ever see the exponent next to the prefix, you just screwed yourself. Bad idea. Okay, they always have to be opposite of each other. Okay, they're always on opposite sides of the factor. Okay, so I'm going to have to now set this up. I want meters to cancel and leave me centimeters. So what goes on top, what goes on bottom? Oh, well, meters is starting out here, right? So I got to put meters on the bottom. So how many meters? Oh, 10 to the negative 2 meters on the bottom, right? And then 1 centimeter on top. So now my meters cancel. Perfect, as they should. And then you can punch that in your calculator. So real quick, I know we're almost out of time. I've got 1 minute. So real quick, try that in your calculator. And again, 10 to the something, try your exponent key. So try to enter it in your calculator, if you can, as 6 divided by, because it's on the bottom, right? So anything on the bottom, you're dividing by exponent key negative 2. And if that gives you a like an error, give you an error on some kind of, then try a 1 in here in front of the exponent and see if that works for you. And you should get 0.06. Okay. Yeah, you're right, Tom. I'm sorry, but yeah, right.
So when I do it, it comes out kind of, it's 6 divided by...
Try the 1. So try the 1. 6 divided by 1 exponent 2. Oh, not 2, I'm sorry. Negative 2, right? There you go. Oh, I'm sorry, 600, the other way. 600. The other way, I'm sorry, 600, the other way. Yeah, I'm sorry, dividing by a negative makes it positive. Sorry, the other way. Okay, right at time, sorry about that. So yeah, okay, well, so next time, then we'll go back and do some more of these and we'll practice. So please, if you can, get a scientific calculator to bring to practice. Don't be using your iPhones. And we will have a metric quiz. So I want you to bring one of those short 815E Scantrons. 815E Scantron. Got me? That's the little short one. It's the little short 15-question Scantron. So bring one of those. And then in the lab afterwards, no, not beforehand, right? Pre-lab questions, little procedure, all that stuff we're going to have to just talked about, okay? All right. So were there any latecomers? I didn't call their name because if not, they were getting dropped. So we never had, Valerie didn't show up. Diana and Alec. Okay. Okay, we'll see you Wednesday morning, 8 o'clock in lab. Thank you.